Welcome to Gateway Learning Center. Today we're going to look at physics. So last time I posted a video. I did a calculation of electricity in both parallel in the series. Now today we're going to focus on power and energy. Then after that we're going to do cost of electricity. So now, when you're dealing with power and energy, these are two common terms which we normally use in the common language. But now in science, power and energy have different meaning. For example, when someone's talking about power, we know we're talking about the ability to do something. That's a common language. But that one, in science, will refer to energy, because energy is the one we say is the ability to do work. So now, what is this energy we're talking about again? So that energy, that definition of ability to do work, will also differ whenever we're dealing with energy in our under electricity. So when electricity is moving around a circuit, we know that a circuit is made up of a conductor. So when electricity is moving from one point to the other, in that conductor, there are other factors, e.g. resistance. So that resistance, to be overcome for electricity to move from one energy or from one point to the other point, it needs energy. And when that resistance is overcome by the flow of electrons through the conductor, which is called current, that resistance will be converted back to it. So that's the energy we're trying to do or to deal with today. So energy under this circumstance will be defined as is the product of potential difference and the quantity of charge through a circuit. So when they say this energy, the product of PD, PD stands for potential difference, and the quantity of charge. So energy is the product of potential difference or voltage and the quantity of charge. Now, what is this charge? We know that charge is the amount of electricity which can either be positive or negative. Charge is measured in coulombs. Capital letter C as the unit. The formula for charge, you find that charge is equal to current times time, where current is in amps or amperes, then time is in seconds, and charge is in coulombs. So this is about charge. Since we are saying it's the product of PD and the quantity of charge, therefore energy or work is equal to PD, voltage, symbol, it is V, then charge, we can put Q. Now for us to calculate this part easily, it will be very wise for us to say charge or potential difference. Where there is charge here, we'll replace now with IT. So I'm going to say IT. So this is charge. So this is the formula now which we can use to calculate charge. From the definition, we know if this is our conductor, so as the current is moving in this direction, in this conductor, there is what we call resistance. So for current to overcome resistance, it needs energy, or it needs to do a certain work. So this energy is being driven by the flow of electrons. So as the electrons are flowing from this position to this position, you need to understand that they are carrying energy. So now, this energy, which is being carried by the flow of electrons, is the energy which will overcome that resistance within the conductor. So when that resistance has been overcome, now it will be turned back into it. So when resistance has been overcome by energy, then that now will be changed into it. With that, then the flow of electrons will be in the movement within a conductor. So this is what energy or work is done. So from here, we're going to look at, let's say, an example. If we have, let's say, a current of 2 amps flows through a conductor which has a resistance of, let's say, 10 ohms. 10 ohms in 2 hours. Then we say calculate the energy which was converted into it. So that's our question we have. Now from this question, we need to get the data. So our data, we have current at 2 amps, we have resistance at 10 ohms, then what else do we have? We also have time at 2 hours. So this is the data which you have. Now for us to find energy, we know that energy or work is equal to VIT, where T, time in seconds, then current and voltage. In this data we have, we don't have voltage. So there are 2 ways we can look for voltage with this question. So let's go back to Ohm's law. We know that resistance is equal to voltage over current. So if you make V the subject of the formula, expecting to get V is equal to Ri. So where there is V, we can replace with this part. Therefore, we can say Ri times I T. So Ri squared T. That's the formula now which we can use to go direct with this question. After we have discovered our formula, we need now to check the units of the variables we have. So we have 2 hours. So these 2 hours should be converted to seconds. How do you do that? We know that 1 hour is equivalent to 3,600 seconds. What about 2 hours? So we'll say 2 times 3,600 seconds. Then from here, 2 by 0, we're going to get 0, here 0, then 2 by 6, we'll get 12, so we write 2, 1, 2 by 3, get 6 plus 1, 7. So we have about 7,200 seconds from hours. Therefore, we'll say, where can I erase? Okay, let me remove the question. Hope you have seen the question. Now from here, we know that energy or work is equal to resistance. We have 10. So 10 ohms by I, current, by 2 amps, then by 7,200 seconds. 10 by 2 by 7,200. So having 144,000 joules. So this was the energy which was being converted into it. So this is how we do calculations under energy. Let us also get another question from the past paper so that at least we can solidify our answer. So I'll pause the video, then I'll restart it with another question. Okay, so this is the question from the past paper, and it came to section A. So a heater is connected to a 200 volts supply. Now, if the heating element has a resistance of 10 ohms, how much electrical energy? So this is our question. How much electrical energy is supplied to the heater in 2 minutes? So the first thing is to get the data. So we know that here, electrical energy or work, we don't have. Then we have voltage at 200 volts. Then from there, we have resistance at 10 ohms. Then the last one, we have time, which is 2 minutes. So this is the data which you have. So once you get the data, we need to understand now how are the units related to the question, or rather to the formula. So we know that electrical energy is equal to voltage times current, then times time. So time here we have 2 minutes. So we need to change minutes to seconds. So 2 minutes multiplied by seconds, so I'm getting 120 seconds. So I'm going to use 120 in the formula. Now, we have voltage. Voltage is here. We have current. We don't have current here. We have time. Time is not here. So we need to ensure that we find ways and means of calculating current. So since we have resistance and we have voltage, we can use Ohm's law to find current. After finding current, now I can use the same value and replace it in the value. Or the other way. We said that Ohm's law is equal to voltage over current. So current will be voltage over resistance. So you can also use this part and fuse it where there is current, because this is representing current. So we'll say V over R times this V now times current. So this part now is this part. So V times V, we're going to get V squared over resistance times time. Then from here, hope you have looked at the question. Or before I finish answering, you can pause the video, and after pausing the video, you can try by answering this question so that you can compare if the answers will be the same. If the answers will be the same, good for you. So now, let me use this part. So we know that V, we have 200. So 200 squared over resistance, we have 10 ohms times time, we have 120 seconds. So if we do the multiplication, we have values now. If we do multiplication, so we have 200 squared, which is 400, then times 120, then we divide by 10. So the answer which we are getting, it is 480,000 joules. So that is how we calculate electrical energy. Then from there, maybe someone will say, this is a wrong way. Let me do something easy. So we can say current is equal to voltage over resistance. Then we know that we have 200 volts over 10 ohms. cancel, so get 20 amps. So from here, you can turn up image or where is equal to voltage, current, time. So we have 200 times current now, we have 20 times 120, which is time. So 200 by 20, then by 120. So the answer is 480,000 joules. So it just depends on how familiar you are with the formula or what knowledge you are possessing for you to do the calculation. But either way, the answer is the same. So this is how we do energy. Next time we're going to deal with power. So remember to subscribe to my YouTube channel so that you can receive as more videos as you want. So thank you for watching.